Okay, well, we are on March 1st, 2020, and this is our science video for Wednesday. So I'm glad that you're joining me for this video as we start this next exciting chapter of science, and we're going to be learning about echinoderms. So the first thing that I need you to do is open your journal so that you can take notes that I write up on the board. So if you are in a junior journal, you're going to be looking for this page to take notes on. It's page 167. And if you are in the regular journal, not junior journal, but regular journal, this is page 152 is where you'll be. Okay? So find your place and then let's get started with our note-taking. So we are on lesson 11. We're approaching the end of the book, and if you are following along in your science book, I'm on page 173. Lesson 11, echinoderms. That's a big word to say, so let's go ahead and write that one down. And we'll practice saying it. It looks like chin, doesn't it? Echinoderms. Echinoderms. How did the starfish and the sea urchin pay for their lunch? Can you guess? They paid with a sand dollar. That's a classic echinoderm joke, since all of those animals are members of the phylum Echinodermata. Echinoderm comes from two Greek words, echino and derma. So echino comes from the Greek word spiny, and derm, if you remember, we've used this one before, means skin. So echinoderms actually mean spiny skin. And as you heard, some of the animals that we'll be learning about are a starfish, a sea urchin, and a sand dollar. Thus, echinoderm means spiny skin. If you have ever felt the skin of a living sand dollar or starfish, you can understand why it's called spiny skin. It has a rough, bumpy texture with little spines found covering it. The animals in this group include the sea cucumber, feather stars, brittle stars, sea urchins, sand dollars, and starfish, which are more properly called sea stars. All these spiny-skinned creatures have a few things in common: no eyes, no brain, and tube feet. So, no eyes, no brain. This kind of looks like our brain. No brain. And they do have tube feet. Tube feet. And we'll learn more about that in a little bit. Tube. Let me do my little tube this way. Tube feet. Okay, these little tube feet are very fascinating. They are essentially tubular strands with suction cups on the end. Echinoderms move by using their tube feet to suction onto a surface and then push or pull across it. They can also use them to hold on to a surface. Sea stars suction onto bivalves in order to force them to open, and sea urchins suction onto hard surfaces to stay in one place. So if you look at the bottom of the page there, you see that you can see the actual suction cups on the ends of the sea star's tube feet as it clings to the side of its aquarium. God designed these little tube feet to do two other important jobs. First, they help the echinoderm breathe. Okay, so the tube feet have two important jobs. They help the echinoderm breathe, In addition to special gills that stick out from the skin, the tube feet take in oxygen from the water and release carbon dioxide as waste. Second, these tube feet are like tongues. They taste everything the echinoderm touches to see what might make a good meal. Since the creature has no legs, no eyes, no nose, these little tube feet are crucial to the echinoderm's survival. Another thing most of these little guys have in common is radial symmetry. What is that, you ask? Well, each of these animals, except for the sea cucumber, has a mouth in the center of its body, and the rest of its body radiates out from the center. So, by radial symmetry, what we mean is if it has a mouth in the middle, and then everything else radiates out from there. Okay? In the case of the sea star, you can see one on that page that has the 5, and then you see that in the middle is where its mouth is. Okay? We're on page 174. Since they spend their time on the seafloor, can you tell me if echinoderms are part of the nekton, plankton, or benthos? Do you remember what those mean? They are definitely part of the benthos. However, like most benthic animals, when echinoderms are larvae, they float about in the water as part of the plankton population. Let's explore some of the different echinoderms in God's creation. Okay, so the first one that we're going to study is the sea star, probably one of my favorites. I think they're very beautiful and interesting. So let's study the sea star. Let me erase this. Make sure you have your notes. Pause it. Get your notes if you need to. Okay. Sea stars. Sea stars are found all over the ocean, from the beaches to the continental slope. They can be as small as your pinky finger. Wow, that's little. Okay? Or they can be 3 feet across. So I want you to take your arms and spread them out. If you're my height, you probably need to pull your arms in a little bit. But if you're in Miss Karen's class, do your arms all the way out. That's how big a sea star can get. They're almost can get as big as you. Most sea stars have 5 arms called rays, like the sun's rays. So let's see if we can do one here. Let's do 1, 2, 3, 4, and 5. So most of the time they have those 5 arms. They radiate out from a central disc, and we're going to call this the central disc. Okay, if a sea star has more than 5 rays, it will often have rays in multiples of 5. There could be 10 or 15, let's count by 5. 5, 10, 15, 20, even up to 30 rays on each star. A sea star's rays come from the central disc, which has a large hole on the underside. Can you guess what that hole is? If you guess their mouth, you're right. Interestingly enough, when it eats, the sea star doesn't use its mouth the way that we do. When you eat and I eat, we use our mouth to take in food and chew it. Then we swallow, and the food travels through our esophagus to our stomach. Well, the sea star is completely different. Their stomach actually goes out of the mouth to engulf the prey. Did you hear that? Their stomach actually comes out. So our stomach is down here. Can you imagine if we had a hole there and our stomach just came out to take our food in? We do ours a little bit different. So when we think of mouth, we think here. But when we're talking about a sea star, we're talking about their mouth is their stomach. Once the stomach has done that, it immediately begins digesting the helpless animal. As the food gets smaller and mushier, the sea star pulls the stomach back through the hole to be fully digested inside. Now that's an odd way of eating indeed. So what is the favorite food for this escaping stomach? Can you guess? Well, it's a bivalve, which we've learned is the favorite of many creatures. The sea star crawls up onto an innocent bivalve like a clam, and it wraps its suction-footed rays around the clam. Then it attaches the suction cup to its tube feet to each side of the clam and starts to pull the clam open. At first, the clam uses its muscles to hold itself closed, but eventually the clam gets tired, and the sea star can open the shell by just a tiny crack. Once it has done that, the sea star's stomach leaves its mouth. Interestingly, the stomach is kind of like an octopus. It can change shape to fit into small cracks and crevices. So if the clam is slightly open, the sea star's stomach can slip right inside and begin digesting the tasty body of the clam. After the sea star has fully digested its meal, waste are eliminated from the anus, which is on the side of the body that is opposite the mouth. If you look at the picture on page 175, you can see its tube feet locked onto that clam. Okay, it's about to eat it. Although you thought the sea star was just an interesting little treasure of the sea, you now realize how ferocious it actually is. In fact, the sea star lumbers across the sand or rocks searching for prey. Believe it or not, sea stars are some of the most numerous predators in the ocean. When a sea star happens upon any edible creature, out comes its stomach to gobble it up. Because sea stars feast on huge numbers of clams in the ocean, people who gather clams for a living have tried for years to get rid of them. In order to kill the sea stars, these clam fishermen would catch them, slice them in half, and toss them right back into the ocean. They believed that this would eliminate the sea stars and keep them from eating up the clams. Do you think this was a good idea? We'll find out in a moment. A sea star's tube feet are concentrated in grooves that run down the center of each ray. These grooves are called ambulacral grooves. Okay, so down the center, like this, we would call these grooves ambulacral. Ambulacral grooves. Now remember that the tube feet help the sea star to breathe. Interestingly enough, the oxygen that these tube feet collect is not distributed through the body by blood. Sea stars don't have blood. Instead, a sea star has a system of canals called the water vascular system that transports oxygen, food, and other things it needs to the different parts of the body. So they have a water vascular system. Sea stars don't respond to touch very quickly. In fact, if you pick up a sea star, you might wonder if it's even alive. Yet, by turning it over and looking at the little moving feet on the bottom, you will see that it is indeed a living creature. Sea stars don't have eyes like you or me. Instead, at the end of each arm are eye spots, which are only able to tell light from dark. If you happen to see a sea star at an aquarium or at the beach, try to find its eye spots. An eye spot is usually colored differently from the rest of the ray, and it's generally at the very tip. Okay, and so I think we'll stop there, and we get to talk about what happens if you tear a sea star in half tomorrow.